On the flight deck of the USS Abraham Lincoln, CVN-72, the United States Navy is testing its most powerful combat systems. From defensive missile systems like the RIM-116 Rolling Airframe Missile, always ready to fire instantly, intercepting and destroying incoming threats before they can close the distance to the F/A-18E/F Super Hornet, cutting across the sky at supersonic speed, carrying firepower capable of overwhelming any target in its path. This is true combat power, pushed to its absolute limit, where reaction time disappears and every mistake is immediately costly. Welcome back to the 21st century, where we show you what others miss. On the flight deck of the USS Abraham Lincoln, CVN-72, a live-fire defensive exercise is underway, conducted under conditions designed to closely replicate real combat. Alongside the carrier, the USNS Arctic, TAOE-8, maintains position, conducting underway replenishment as containers of RIM-116 Rolling Airframe Missile are craned onto the deck. Each sealed canister is aligned and loaded directly into the Mark 49 launcher. The mount weighs approximately 12,700 pounds and carries up to 21 missiles, forming a dense layer of close-in defensive firepower. Once loaded, the system is immediately combat-ready. The RIM-116 ram was built for the final seconds. With an engagement range of roughly 6.2 miles, it creates a hard defensive envelope against incoming threats, from sea-skimming anti-ship missiles to asymmetric aerial targets. Its fire-and-forget capability allows each missile to guide itself after launch, minimizing reaction time and reducing strain on the ship's combat systems. During the exercise, multiple simulated targets are launched from different directions, replicating a saturation attack. As they cross the detection threshold, the ship's combat system locks on. The launcher pivots, and ram missiles fire in rapid succession, intercepting threats before they can enter the danger zone. This is the last line of defense, where precision is absolute. Developed jointly by the United States and Germany, RAM is more than a missile. It is a complete close-in defense system, compact, fast, and built to defeat modern threats with decisive effect. Following the live fire sequence aboard the USS Abraham Lincoln, the test shifts from firepower to system intelligence. Over time, RAM has evolved through three main variants: Block 0, Block 1A, and Block 2. Block 0 laid the foundation, combining technologies from the FIM-92 Stinger and AIM-9 Sidewinder into a compact, highly agile design. Block 1A introduced full infrared guidance, allowing the missile to independently acquire and track targets throughout its flight, a critical advantage against modern low-signature threats. This becomes especially critical against modern anti-ship cruise missiles, which increasingly limit radar emissions to avoid detection. With Block 1A, RAM is not just fast, it can effectively see its target under a wide range of conditions. At the top of the evolution is Block 2, the most advanced version to date, which entered service in 2014. Featuring a redesigned control section with 4 additional control fins, the missile's maneuverability is significantly enhanced. It no longer follows a simple trajectory, but continuously adjusts its flight path in mid-air to track fast, maneuvering targets. A more powerful rocket motor further increases acceleration, reducing time to target and compressing the enemy's reaction window to a minimum. In terms of specifications, each RAM missile measures approximately 9.2 feet in length and weighs around 162 pounds, making it compact enough for integration across a wide range of naval platforms without imposing significant space or weight penalties. Its warhead, weighing about 22 pounds, is a high-explosive fragmentation type designed to detonate on impact or in close proximity, generating a lethal fragmentation field capable of destroying or disabling targets in an instant. What truly sets RAM apart is its dual-mode guidance system. It uses passive radar homing to detect emissions from the target, then transitions to infrared tracking in the terminal phase to ensure precision. This combination allows the missile to remain effective even when facing targets that attempt to minimize radar signature or execute sudden evasive maneuvers. During flight, the missile spins along its longitudinal axis, a unique design that provides aerodynamic stability without the need for complex control systems. This not only reduces cost, but also increases reliability in harsh combat environments. Aboard the USS Abraham Lincoln, Mark 49 launchers are positioned along the edges of the flight deck and around the island superstructure, ensuring maximum coverage and firing angles. Each launcher carries 21 missiles, ready to form a dense interception grid within the ship's point defense envelope. Working together, they turn the ship into a target that is nearly impossible to approach at close range. During the test, as simulated targets maneuver aggressively at high speed, it is the Block 2 variant that clearly demonstrates its edge. The missile doesn't just pursue, it adjusts course mid-flight, cutting angles and maintaining a hard lock until the moment of impact. That is when it becomes unmistakably clear. This is not just a defensive system. This is the last line of protection, where technology, speed, and precision converge to ensure that any threat approaching the USS Abraham Lincoln is neutralized before it can cause damage. The exercise doesn't stop at the surface or below it. Aboard the USS Abraham Lincoln, it extends into the air, where one of the primary strike platforms of the United States Navy enters the fight. The F/A-18E/F Super Hornet, which captured global attention in Top Gun, Maverick, is no longer just a cinematic icon. It is a real-world warfighting asset. What audiences saw on screen is only a fraction of its true capability. In reality, its modern design, high speed, and heavy payload give it the ability to dominate a wide range of targets. On deck, engines roar to life. A Super Hornet is brought into launch position, fully loaded with weapons. There is no room for error. The steam catapult fires, and in an instant, the aircraft is hurled off the deck, surging into the sky with full power. Developed from the F/A-18 Hornet, the Super Hornet first flew in 1995 and quickly became the backbone of U.S. naval aviation. With continuous upgrades, it is not just a fighter jet, but a true multi-role platform capable of adapting to the full spectrum of modern warfare. In the test scenario, the F/A-18E/F Super Hornet does not fly a simple straight path. It maneuvers aggressively, changes direction, climbs, then dives, simulating both air-to-air combat and precision strike profiles. At the same time, it can seamlessly shift roles, from air superiority fighter to ground attack platform, and then transition into reconnaissance. One platform, multiple roles, no interruption. The nickname Rhino is no coincidence. Its distinctive forward fuselage and larger airframe give it a heavier appearance, but underneath is a machine built for agility and endurance. Since entering service in 1999, the Super Hornet has replaced the F-14 Tomcat and quickly proven its value across every operational environment. From the United States to Australia and Kuwait, its widespread adoption reflects a level of reliability and versatility that few aircraft can match. But to fully understand where that capability comes from, it's worth looking back at its predecessor. During the Gulf War, the F/A-18 Hornet not only engaged in air combat, but also carried out precision strikes against strategic targets, even returning safely after taking hits from surface-to-air missiles. Back over the skies of the USS Abraham Lincoln, the Super Hornet continues its flight pattern, still carrying a full weapons load. This is not a demonstration. This is part of a larger test sequence, where every system, from subsurface to air, is integrated into a unified combat network. As the larger and more powerful successor to the F/A-18 Hornet, the Super Hornet boasts a maximum takeoff weight of 66,000 pounds, a combat radius of approximately 1,275 nautical miles, more than 50% greater than its predecessor, and speeds reaching Mach 1.6. That performance is driven by two General Electric F414 engines, each producing up to 17,000 pounds of thrust, turning the aircraft into a platform that is both powerful and highly adaptable. But raw power is only part of the equation. Its aerodynamic design allows it to sustain high speeds while executing complex maneuvers, from close-range dogfights to evading surface-to-air threats. Combined with advanced avionics, it can detect, track, and prioritize multiple targets at long range, giving it a decisive advantage before the engagement even begins. Its weapons loadout reflects its true multi-role nature. In air-to-air combat, it carries missiles such as the AIM-1, 2, OAMR, AAM, and AIM-9 Sidewinder. When shifting to ground attack, it deploys AGM-65 Maverick, AGM-84 Harpoon, along with precision-guided munitions such as JDAMs, and a 20mm cannon for close-range engagements. One platform, covering the full spectrum of modern combat missions. In operational history, the F/A-18E/F Super Hornet has been present in a wide range of major campaigns, from Operation Southern Watch to Operation Enduring Freedom, Operation Iraqi Freedom, Operation Odyssey Dawn, and Operation Inherent Resolve. It has not merely been present, it has actively engaged in air combat, executed precision strikes, and maintained sustained pressure on the battlefield. Back in the cockpit, where the pilot commands the entire machine, the Super Hornet continues to demonstrate its edge. A large area display presents real-time battlefield data, giving the pilot a clear and comprehensive picture, almost as if looking directly through the battle space. Every target, every threat is presented intuitively, reducing decision-making time to the absolute minimum. Above the USS Abraham Lincoln, as subsurface and surface systems complete their phases of the test, the Super Hornet closes out its flight pattern at high speed, still carrying a full weapons load. This is not a demonstration. It is proof of how the United States Navy integrates firepower, technology, and rapid response into a unified combat system, where every platform, from defensive missiles to supersonic strike fighters, functions as part of a fully optimized warfighting machine. In reality, what is being tested aboard the USS Abraham Lincoln does not exist in isolation. It directly reflects how the United States Navy prepares for high-tension regions, particularly the Middle East, where strategic maritime routes remain highly sensitive. In a hypothetical scenario, if tensions escalate in the Strait of Hormuz, carrier strike groups would play a decisive role in controlling the airspace and safeguarding commercial shipping. In this environment, the F/A-18E/F Super Hornet is not just a fighter aircraft, it is a rapid response asset, capable of launching on short notice to intercept, escort, or conduct precision strikes. Meanwhile, onboard defensive systems such as the RIM-116 Rolling Airframe Missile form the final protective layer, ready to counter threats like anti-ship cruise missiles or low-flying UAVs, which are characteristic of asymmetric warfare in the region. Another possible scenario involves low-intensity encounters, where a target is misidentified or an aircraft approaches too closely. In the confined operating space of the Middle East, such incidents can escalate rapidly. In those moments, the Super Hornet would be the first to respond, establishing control of the airspace, while the ship's defensive systems remain on high alert against any unexpected threat. What stands out is that these scenarios are not purely hypothetical. They reflect how modern naval forces operate in high-risk environments. A tightly integrated network of surveillance, strike, and defense, where the F/A-18E/F Super Hornet and the RIM-116 Rolling Airframe Missile do not operate independently, but together create a layered, comprehensive zone of control from below the surface to the skies above. But what happens when that system is pushed to its limits in a real conflict zone, where reaction time is measured in seconds and every decision carries consequences? That answer is still unfolding. Stay tuned for the next video.